Let's use the law of sines when we're solving to find missing parts in a non-right triangle and we know an angle and its opposite side. Use the law of sines when, I'm going to write that first part I said. Solving, kind of backtracking here, to find missing measurements in a non-right triangle, and we know an angle in its opposite side. For example, if we drew it out and we had labeled them like A, B, C, we would know big A and little a, or big B and little b, big C and little c. By the way, I sort of halfway lied to you. This does work with a right triangle, but generally we'll just use right triangle trig for things like that. Use the law of cosines when, well, same situation here, solving to find missing measurements in a non-right triangle, and we do not know an angle and its opposite side. Okay? Triangular pasture is made by fencing in the area around 3 posts. Post A and B, and then there's a post C. So let's just kind of glance over the problem, which we just did. A, B, C. We know we have a triangle. We know it's got an A and a B and a C. So let's just go ahead and draw it. Doesn't have to be perfect. Posts A and B are 62 feet apart. B and C are 57 feet apart. Posts A and C are 43 feet apart. What's the angle of the fence at post C? So they're asking for this little angle right here. I'm going to call him theta. So they gave us little c, little a, and little b. And big angle, big letters are across from little letters. The angle is the big letter, the capital letter. The side is the lowercase letter. Okay, we do not know big A and little a, big B and little b, big C and little c. We don't have a single pair of angle and side. So what we're going to have to do is use the law of cosines. Since we're looking for C, we're going to pick the one that starts with the letter C. So we're going to use that one right there. C squared equals A squared plus B squared minus 2AB cosine big C. All right, let's fill some numbers in. We know little c is 62. This is the easy part. We're just going to fill in the numbers. 57 squared, 43 squared minus 2 times 57 times 43 times cosine of big C. Okay, more than likely your answers will be in degrees, so let's press mode. Make sure you're in degrees. If you're not in degrees, you're going to miss this problem. We're solving to find C, so we are going to have to move these things over one at a time. So here goes. 62 squared minus 57 squared minus 43 squared. And we'll stop right there and take a break, because if we were to continue going, we'd have to divide and it would mess us up. All right, now we'll start dividing. Divide by -2. Divide by 57, divide by 43. Now we're here to this cosine. Inverse cosine of that last answer, 75 degrees. Okay, next problem. Greg and Elmer, our children, lying on the ground looking up at the sky. Draw it. Lying on the ground. Here's Greg. Here's Elmer. Looking up at the sky, they're lying 20 feet apart. And they gaze up at a bird's nest in the top of a tree. So here's this tree. There it is, a skinny little tree. And there's a bird up there, a little nest. I can't draw. Greg's looking up. Elmer's looking up. There we go. And there's a bird. I'll call that Big B. Okay, now we're going to look at the big triangle. We're not really going to worry about the tree. Later on, the fact that this is a right angle is going to come in handy, but for now we're dealing with the big thing. So Greg looks up at an angle of 62 degrees. I'm going to label that in red. Elmer looks up at an angle of 40 degrees, and before I read anything else, let's go ahead and do something that's fairly obvious. 180 degrees minus 62 minus 40 is going to give me big B, and that is 78. It is not going to be split in half by that tree. It is not, so don't even try it. But we do know that whole thing across there is 78 degrees, the entire thing. How far are Greg's eyes from the bird's nest? We're looking to see how far Greg's eyes are from the bird's nest, and that actually is little e because it's across from big E. So let's figure it out. We do not know big E and little e. We do not know big G and little g, but we do know big B and little b. So we're going to use the law of sines this time. Sine of big B over little b equals sine of big E over little e, and we'll fill the numbers in. So sine of 78 over 20 equals sine of 40 over E. We will cross multiply. 20 times sine 40, so sine 40, put the 20 in the front, equals E times that. So E times sine of 78. And that's great, but we're looking for E, trying to solve for E, so let's divide by sine of 78. Divide by sine of 78. E equals that mess right there. Type it in. Make sure you have your parentheses in the right place. 20 sine 40 divided by sine 78. 13.14. Yeah. There we go. And this is what? Feet? Yeah. 13.14 feet. There it is. 13.14 feet. That's what it is. Using the same information, how tall is the tree? So now we're wanting to know that right there. We're wanting to know that length. So let's redraw this thing. But we're just going to deal with the right triangle this time. So this is 13.14. This is a right angle. This is 62 degrees. And then they're asking for the height of the tree. Now, again, don't chop the 78 in half and put half of it over here. That's not half of 78. This is not half of 20 because this is not an isosceles triangle. Okay? But we do have an angle, and we are looking for the opposite side, and we have the hypotenuse. Opposite and hypotenuse is sine. So the sine of 62 degrees equals opposite over hypotenuse. We will multiply 13.14 times sine of 62. We are already in degrees. 11.6. This tree is 11.6 feet high. Not a very tall tree. Not a very secure bird. Okay, down at the bottom, it's a complete shift of, pardon the pun, shift, get it? It's a complete shift from what we've been doing up at the top of the page, because this kind of stuff was solving to find missing parts of a triangle using trigonometry, and this is going to be graphing trigonometric functions. And basically, these are the kinds of graphs that go like this. And they're periodic because they repeat themselves in a cycle. So we're just going to identify the main parts of it and go on from there. First of all, this is the amplitude. Always make it positive. This is not the period, but it helps determine the period. So it is 360 divided by this is the period. And I said 360 meaning degrees, but it could be 2 pi if we're dealing with radians. So 360 degrees is one way of measuring the entire distance around a circle in terms of angles. But we can also deal with it in terms of radians, which would be 2 pi radians. Different way of measuring angles. This number right here is the horizontal shift. There is an exception to that. And this number at the very end that you don't see is the vertical shift. Now that we've drawn all over this problem, let me point out a couple things. Sometimes the vertical shift will go in the front. For example, let's look at this last one. It might say, for example, instead, it might say 1 minus 2 sine of 1/2 x. In this situation, the 1 has been moved from the back to the front, but it's still the vertical shift because it's not really connected to the term that has the sine or cosine with it. Okay, let's go back through here and draw some answers out. Amplitude in this case is 3, positive 3. The period is whatever 360 divided by 2 is. 360 divided by 2 is 180. It takes 180 degrees to make a complete cycle. The horizontal shift is not 90. I did sort of lie to you a little bit. It is negative 90. It's always the opposite. So let's go in here and let's write this down. It is the opposite sign. There's still one more exception. We'll get to that in just a minute. And the vertical shift in this case is 0. If we were to graph it, it would be centered around the x-axis at 0. It would have the x-axis and it would just kind of go from there. Okay, amplitude in this case is 1. Period in this case is not 2, but it is 360 divided by 2, which is 180 degrees. While I'm here, I'm going to do this also. If they have it in radians, you do 2 pi divided by 2, which would just give you pi. Horizontal shift, this is where it's about to get crazy. You're probably wanting to put a negative 90 down, and you can't. Why? Because it looks like the last one. Actually, no, it doesn't look like the last one. Notice in this case, the 2 was factored out of that. Like there was a 2 and then the parentheses. In this case, it's not that way. So we could rewrite this one as cosine of 2, and then we're going to factor out that 2 from everything that's left in here. So we have a 2, and then 90 divided by 2 is 45, then plus 4. So if we were to distribute that 2, that's what we'd have. This is just the way the basic formula works. I just wanted you to identify the difference between this one and this one. So the horizontal shift is actually not even 45. It is negative 45. So if we were to start, we would slide it over to negative 45. Vertical shift is positive 4. Okay, amplitude in this case is 2, not negative 2. Amplitude is the measure of how much it goes up or down. Now we would start by drawing it downward because it's negative, but amplitude is 2. The period is 360 divided by a half. Be careful if you put it in your calculator, put it in parentheses. That is 720 degrees. Horizontal shift, there is none. There is nothing else over here, so that is 0. And the vertical shift is 1.